All right, so let's go ahead and get into chapter 9, chemical bonds. You will have a part 2 of that homework that's going to be due on Monday. And I have put that on Moodle already, and we'll discuss that a little bit more a little later on. All right, so compounds and chemical change. All right, so the atom is the smallest unit. It's made up of electrons, protons, neutrons. We've already discussed that. And the compounds are formed when you have atoms that are held together by an attractive force called a chemical bond. So those chemical bonds bind those individual atoms together to make up the compound. Right? So a compound is just a addition of individual atoms held together by a chemical bond. So your molecule, this is your tightly bound group of atoms that maintains its identity. All right, so a molecule is defined as the smallest particle of a compound or gaseous element that can exist and still retain the characteristic chemical properties of the substance. So your compounds are naturally occurring, so they can be in gas form, liquid form, or solid form. Okay, so many common gases occur naturally as the molecules that are made up of two or more atoms. Okay, two or more atoms make up a molecule. So both hydrogen and oxygen occur naturally in a diatomic molecule. So di means two. All right, so oxygen, O2, and hydrogen, H2, both are diatomic molecules. So you have two um, atoms of hydrogen and two atoms of oxygen. And so your oxygen sometimes occurs as molecules of three oxygen atoms, and that's what we call ozone. So ozone is when you have three oxygen molecules that makes up that molecule. All right, so when there's three, we call it triatomic molecule. So tri means three, like tricycle has three wheels. A trike is a bicycle that has three, wheels. So um, tri means three, di means two, and then mono means one. So if you have a monatomic atom or compound, um, that just means one single um, atom or compound. All right, so diatomic is two, monatomic is one, and triatomic is three. Okay, so on to chemical reactions. All right, so when you have molecules of any size that are formed or broken down into simpler substances, those new materials have new properties. All right, so it's the kind of change in matter, and this is what we call a chemical change. All right, it goes through a process called a chemical reaction. So a chemical reaction, this is when you have a change in matter or material, in which you have different chemical substances that are created by the breaking or forming of chemical bonds. So your chemical energy, this is produced. So your energy is absorbed to produce new chemicals or new chemical substances with more potential energy. And then when you have energy that's released, that's when you have new chemical substances that are produced with less internal energy. So in general, those changes in the internal potential energy are called chemical energy. So when you have new chemical substances that are produced in, let's say, green plants through photosynthesis, this is where a chemical energy or chemical reaction can occur. All right, so if you haven't heard of photosynthesis, which I think this is taught in biology, beginning biology, intro to bio. This is when you have a green plant that uses radiant energy. So it uses the sun rays from the sunlight. It has carbon dioxide and water, and it uses those to produce new chemical materials and oxygen. All right. So if you've heard of, they say, trees, help clean the air. And it's true, it absorbs some of the carbon dioxide and it lets out oxygen. All right, so these chemical materials, the stuff that the leaves and the roots of the plant and the wood are made of, they contain more chemical energy than carbon dioxide and water that they were made from. All right, so it takes carbon dioxide, water, and sunlight to produce these new materials that grow onto the plant. All right, so this is what a chemical equation looks like. So what is a chemical equation? It's a way of describing what's happening during a chemical reaction. All right, so on your left-hand side is your ingredients, and on the right-hand side is your products. All right, so this is for the chemical equation for photosynthesis. So on the left, we get energy in combination with carbon dioxide and water, and we'll eventually get new plant materials and molecules to grow, and then that plant will let out oxygen molecules to clean the air. All right, so the substances that are changed on the left hand side, these are our reactants. All right, so our ingredients. Right, so your reactants, once they get together and they do their chemical reaction, they yield products. Okay, so this arrow right here is almost like the equal to sign in a math problem. All right, so this arrow means yield. All right, so your products, your reactants on your left hand side, they yield the products on the right hand side of this equation. All right, so the arrow means yield. All right, so the new chemical substances that are on the right, they are called products. All right, so if you were to read this chemical equation, it would sound like carbon dioxide and water use energy from the sun to react and yield plant material products and oxygen molecules. All right. On to valence electrons and ions. All right, so in the outer orbital, we have the outer electrons, and these are called valence electrons. All right, it's the valence electrons that participate in the chemical bonding. So they jump from one atom and molecule to the next. So the inner electrons, these are more stable. All right, so they fully occupy the orbitals, but they don't participate in the chemical bonds. They just stay still. All right. So the octet rule, this is when you have noble gases, and noble gases are, they have the outer orbital that's filled with electrons. All right, so they don't normally form compounds. All right, they're half filled. The half filled and filled orbitals are mostly stable arrangements. So atoms try to seek stability, right? That's what they're trying to gain. And they fill those outer orbitals to become noble gases. So noble gases, this is a stable compound. So for represented elements, the octet rule is where you have 8 electrons in the outer orbital. So 2 to the north, 2 to the south, 2 to the east, 2 to the west. All right, so you fill your outer orbital completely. That is called the octet rule. All right, back to chemical bonds. So there's several different types of chemical bonds. All right, there's the ionic bond, the covalent bond, and the metallic bond. So anytime you have atoms that gain or lose electrons through a chemical reaction to, achieve some sort of stability, all right, of a noble gas, the resultant reaction in that chemical bond tracks the forces that holds the atoms together in the compound. All right, so again, there's 3 types of chemical bonds: ionic, covalent, and metallic. All right, so your ionic bonds, these are formed when you have atoms that transfer electrons to achieve the noble gas arrangement. So those electrons are made up or acquired in the transfer. So they form the positive and negative ions. So your your electrostatic attraction between opposite charges, because opposites attract, don't forget that. That's what forms the ionic bonds. And then those compounds are the result of that ionic bond. Right? So in ionic compounds, this is formed when you have metals from the left side of the periodic table that react with non-metals from the right side of the periodic table. All right, so opposites are attracting here in the ionic bond. All right, number 2 is the covalent bond. And this is a result of when you have atoms that achieve the noble gas electron structures. All right, so that means 8 electrons in the outer orbital. And those covalent bonds are formed between non-metallic elements on the right-hand side of the periodic table. All right, so ionic comes from metal from the left side of the periodic table and non-metal from the right side of the periodic table. For covalent, this is generally all non-metal materials. So these are the elements from the right side of the periodic table. And then last but not least, you have your metallic bonds. So these are your metals. All right, so your metallic bonds, they're formed when you have those solid metals such as iron and copper, and other metallic elements that pretty much make up 80% of all the known elements. So the atoms of metals, they're tightly packed and they share many electrons that are free to move throughout the metal. All right, so this is why metals are conductors, because those electrons can move freely throughout the metal. All right, so your metallic bonding accounts for metallic properties such as high electrical conductivity. So this is why metals are conductors, because these electrons are free to flow through them. All right. All right, so you have energy and electrons and ionic bonding. So let's say we have sodium and chlorine, which is your table salt, and you separate the sodium and the chlorine into their individual parts of atoms. All right, the overall effect is that the energy that's released and an ionic bond is going to be formed from that separation. All right, when the energy is released, that's called heat of formation. All right, this is what occurs when energy is released. So it's the amount of energy required to decompose the compound into its individual elements. So instead of it being sodium chloride, it's going to be split up into sodium atoms and then split into chlorine atoms. All right, ionic compounds and formulas. All right, so if you remember sodium chloride, that's if you've taken biology or intro to chemistry already. Your sodium is Na and your chloride is Cl. All right, so sodium chloride is NaCl. So you take those individual shorthand compounds and you put them together. All right, so if it were to have a subscript, that'll let you know how many atoms are in the molecule. So for example, calcium fluoride, you have 1 calcium and 2 atoms of fluoride, right? So those little subscripts tell you how many atoms exist into the compound, all right? Back to covalent bonds. So most substances don't have the properties of ionic compounds, all right? So most of these substances are, molecular substances. So they're composed of uh, electrically neutral groups of atoms, and they're just tightly packed together. All right, so many gases are diatomic, which means they naturally occur 2 at a time. So hydrogen usually comes 2 atoms at a time. Oxygen comes with 2 atoms at a time. So again, they're held together by covalent bonds. All right, so the covalent bond again is the chemical bond formed from sharing at least a pair of the electrons. All right, so that was your old homework assignment. All right, so your covalent compound. So this is when you have a compound that's held together by the covalent bond called the covalent compound. All right, and they form from non-metallic materials on the right-hand side of the periodic table. And then there's multiple different types of bonds. All right, so you have a single bond. This is when you have a single pair of electrons shared by two atoms. A double bond is when you have two pairs of electrons that's shared by two atoms. And then triple bond is when you have three pairs. So single bond, one pair, double bond, two pairs, and then triple bond is three pairs of electrons that are shared between those two atoms. All right. Then you have bond polarity. So your electronegativity is comparative to the ability of atoms of an element to attract bonding electrons. And then your polar covalent bond is a covalent bond in which there is unequal sharing of bonding electrons. So there's like an odd number out. All right, so that was the gist of chapter 9.